Hello, good morning, student. Today, what we are going to learn, we are actually talking about the protection and deprotection. As we know that protecting group means what? Protecting means temporary modification of the functional group is known as a protecting group, right? So, for ideal protecting group at the beginning in the first lecture, we already learned what are the ideal criteria or the characteristic of protecting group. Means the ideal or the important characteristic of the protecting group. First one, it should be introduced under a mild condition. Number two, it should be removed under mild condition. And number three, it should be stable at the reaction condition necessary carry out the transformation. These are the three things required for ideal protecting group. So today, so far we have seen, we are talking about the protection of the hydroxyl group. So far we have seen so many protecting group which can protect the hydroxyl group. Today specifically we are going to learn the protection as a silyl ether. And as we know that silyl ether, the general formula of silyl ether will be this one, ROSI, R1, R2, R3 represent different alkyl groups. And silicon, it is one of the element here forming the bond with that oxygen, and we are getting that primary alcohol specifically get protected by this silyl group. So there are the different silyl reagent which can protect the silyl, which can protect the primary alcohol. Number one is a TMS Cl. TMS Cl means what? Tri-Methyl Silyl Chloride. First one, here we are going to learn about first one is a first group is a TMS Tri-Methyl Silyl Chloride. What will be the structure of the full form of TMS? What is it and what are the structure of it? Let us see here. Tri-Methyl Silyl Chloride, it is called as Tri-Methyl Silyl Chloride. This is the full form of TMS and Cl for chloride, right? What will be the structure? Let us see here. Tri means there are the trimethyl silyl chloride. Remember, silyl chloride means silicon joined with that chlorine atom. That's it. Now here R1, R2, R3. Here all are the R1, R2, R3 are identical, and therefore we can draw the very simple structure CS3. Here CS3 and here CS3. This is the structure of trimethyl silyl chloride. And as we know that methyl group can be represented by Me. Me is nothing but as a this methyl group. We can call it as a methyl group here, right? Or Et means what? It is a ethyl. CH2 CH3. It is termed as a ethyl, as you know that. Or pH means what? Phenyl. pH means it is a phenyl group. Phenyl, and it is here pH means here phenyl group. Structure is like this, benzene ring, mono substrate, and it is known as a phenyl group, right? So these are the some of the acronym you must remember. So this is the structure of trimethyl silyl chloride. Now Here how, let us see, as we know that the general formula of alcohol is this one. For example, we have a general formula of alcohol is ROH, or maybe aliphatic or aromatic, it doesn't matter. So here what we are introducing, and now remember here we are introducing this Silyl Tri-Methyl Silyl chloride under the basic condition, and therefore we are using here short form here TMSCl in presence of pyridine. Py is called as a pyridine, and as we know that the function of base, that base will abstract the proton and negative charge come on that oxygen atom, and that becomes as a more nucleophilic in nature, that is going to attack on that Silyl, and chlorine is a departure. So we are going to get here RO, then what we can call as the TMS. TMS means trimethyl silyl chloride, or we can represent it like this: RO, then Si, this Me, and Me, like this. You can represent this. This is the protection, and this alcoholic group get protected. This is known as a Silyl ether. That is a Silyl ether. This is called as a Silyl ether, and this Silyl ether is a stable under basic condition, because as we know that the main thing or main application, or what we can call it as a main advantage of protecting group, why we are protecting, because if the organic compound containing as a number of functional group, multiple functional groups are present, and we have to carry out the reaction at particular center at only one functional group we are going to change, but other functional group is more reactive than the later one, and therefore there is a necessary to protect that group, and then the reaction are carried out at a reaction condition, and before that we are introducing the protecting group for the most reactive element, and then reaction carry out. During that reaction, the whatever group we are introducing, it should be stable, and if that silyl ethers are stable at basic condition, as well as whenever we are oxidizing some of the functional group, or you are carrying out the reaction or the reduction reaction, it is highly stable, it does not get disturbed during that reaction, and whenever the whenever we are getting the desired product, we can remove that protecting group by using we can remove it under the mild condition. Here we can use for deprotection by using as a what we can call it as a in acidic condition, or special reagent is used here like as a Tetrabutyl ammonium fluoride or potassium fluoride. So that are the, let us see first here how it is protecting. And for deprotection, what do you get? If you treat this compound with, if you treat this compound in an acidic medium H+, or specifically we can use here this one Bu4NF, or we can use it KF, potassium fluoride. These are the very good reagent which can deprotect the silyl group. Here remember, the fluorine atom is having great affinity with the silicon, and therefore it get easily removed, and we will get the our original compound, that is alcohol back, and then rest of the things. So this is the protection and the deprotection. This is a general reaction you should keep in mind while talking about the Silyl chloride. When this KF or fluorine, why fluorine has a great affinity with silicon? If you remember, as a Wittig reaction, during the Wittig reaction we are synthesizing or we are introducing the carbon-carbon double bond by converting the carbonyl group. Then we can specifically, that is a regioselective reaction, we can obtain by using as a Wittig reaction. Why? Because there is a phosphor and the oxygen atom has a great affinity. The bond, strong bond is formed there, and we are getting as a formation of the olefin in the Wittig reaction, and that's why Wittig received the Nobel Prize for this reaction. But here, similarly, here fluorine and silicon has a great affinity, and that's why the deprotection are easily carried out under the mild condition. Now let us look at the mechanism of protection, how it get protected. Let us see the mechanism of protection. Mechanism of protection. Here, mechanism of protection. Mechanism of protection. Mechanism of protection. First, as we know that the starting compound is alcohol, OH, right? That will be treated with the pyridine, is a base, and as we know that the function of pyridine, which will abstract the acidic proton, and then negative charge develop on that oxygen atom, and hydrogen goes along with the pyridine with base. Now then this will be treated with Tri-Methyl Silyl chloride. As we know that Tri-Methyl Silyl chloride, Cl, then we can write Me, then Me means methyl group, Me, and now this negative charge directly attacking on the chlorine atom, and there is a departure of chlorine atom, and we are going to get the product here RO, then Si, here Me, then Me and Me, right? This is the simple mechanism of protection. Now let us look at the second one, mechanism of deprotection. Now is a mechanism of deprotection. Mechanism of deprotection. Mechanism of deprotection, let us take is this, consider as this structure once again, RO, then Si, here methyl group, another methyl group, and here another methyl group. Now we can treat with Bu4NF, this, or you can use as a KF. This is a source of chloride ion. Now here this Bu, the full form of that, this one Bu4NF is known as tetrabutyl. This one is a tetrabutyl ammonium, tetrabutyl ammonium fluoride. This is the full form of that Bu4NF, tetrabutyl ammonium fluoride, and KF, as we know that K means potassium fluoride. Now here what is happening there, the fluorine atom, this F minus is attacking on that silicon, and this silicon and this bond get glued here, and we are going to get RO here. On protection, maybe it is abstracting from the water, we will get the alcohol back. That is a simple mechanism of deprotection. Or if you treat this compound in an acidic medium, still we are going to get here, or we can show the mechanism here. Let us see this one. Here I am. Here take down the example RO, then Si, Me, and then Me. That will be treated with H plus. What is going to happen? This H plus, now lone pair which is present on the oxygen atom attacking on that proton, and we are going to get RO, then H, then Si, this methyl group. This is also as a methyl group. This is also as a methyl group. Positive charge comes on the oxygen atom. Whenever the positive charge coming on the more electronegative element, that species becomes as a less reactive. Now then there is a water molecule. This is going to attack on that silicon. This bond get cleaved, and we are going to get our main product, that is a alcohol back, and then don't think about the side product. So this is a mechanism of protection as well as deprotection. So this one is a very simple protecting group. So here what are the point to remember? Now is the second one. As we know that the mechanism of all this thing, now second one we are going to learn only the remaining reagent, what are their full forms or how they are. When the protection is done, the reactivity of that particular functional group becomes as a less, and therefore we can carry out the reaction on a desired functional group. We will get our desired product. So that is the main objective of this protection and the deprotection. Now let us look at as a second reagent which we are going to see here. Let us see, here is a TBDMSCl. So TBDMSCl, what will be the full form of this? TBDMSCl, T stand for Tri-Butyl. This is a Tri-Butyl dimethyl Silyl chloride. This is the full form of TBDMSCl. Now Tri-Butyl dimethyl Silyl chloride, and as we know that Silyl chloride, this is a fixed Cl. Now remain Tri-Butyl or tetrabutyl, we can write like this, and then dimethyl means there will be a 2-methyl group attached over there. This is known as a tri-butyl dimethyl. 2 methyls are there, therefore 2-dimethyl Silyl chloride. This is the structure, and as we know that the reactions are again very simple. ROH, that will be treated with this one, TBDMSCl in presence of pyridine. What do you get? You are going to get RO, then TBDMS, tri-butyl dimethyl Silyl chloride. So that will be the general reaction. And how will you deprotect it? Or you can, when the bulkier group introduced at this position, the reactivity of that particular functional group is strongly decreased, and therefore it is superior as compared to as a trimethyl Silyl chloride, and it will be further treated with Bu4NF, or we can call it as a KF, potassium fluoride. Tetrabutyl ammonium fluoride or potassium fluoride, it will deprotect and you will get as a ROH, butyl chloride back here. So this you can represent this one RO, then Si, then methyl group, and then this Me, you can write Me, here also Me, and the Me. That's it. So this is the second one. Now let us move on to the third one. Which is the third one? Let us see here. Third one will be the third one, that is TiPsCl. The full form of TiPsCl will be, what is that? T means triisopropyl silyl chloride. Triisopropyl silyl chloride. Triisopropyl silyl chloride, that is the full form of TiPsCl. When you know the structure, you can easily remember the name of this triisopropyl silyl chloride. As we know that first one everywhere is a, you must remember, that is a SiCl means silyl chloride. Now triisopropyl means this three isopropyl groups are attached here. CH3 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 CH3. These are the three isopropyl groups are there, and therefore it is called as a triisopropyl silyl chloride, and it is a function similar to as a TMS, tri-methyl silyl chloride, right? It is so simple. Let us see here. Again is a same reaction. Take down the starting compound is ROH, that will be treated with this one, this group. As we know that the group will be like this, TiPsCl, then you are going to get RO, TiPs, and you can represent this maybe as RO, then Si, then this one, right? And it will be removed by using the same reagent. We can use here Du4NF, or you can use as a KF. Tetrabutyl ammonium fluoride or potassium chloride, or we can use, here is a H plus in presence of water, or H3O plus. So that are the reagent which we can remove the this group very easily. So that is there. Now let us look at as the last one, fourth one. The name of that compound is the, what is that fourth one? Fourth one will be the TBDPsCl. TBDPsCl, what do you mean by TBDPs? What will be the full form of this? The full form of that TBDPs, it again as a Tri-Butyl Diphenyl silyl chloride. Silyl chloride, this will be the full form of that Tri-Butyl triphenyl silyl chloride. So here, as we know that tertiary butyl or tri-butyl, we can call it as instead of tri, you can call it as a tertiary butyl, not that tri, I think. Tertiary butyl diphenyl silyl chloride. Again you make the correction here. Tri-butyl dimethyl silyl chloride. There I think I have mentioned there is a tri, not that tri, that is a tertiary butyl dimethyl silyl chloride. This is a tertiary butyl. That correction you can make here. Now here tertiary butyl diphenyl silyl chloride. As usual, remember silyl chloride means here SiCl, right? SiCl, and after that tertiary butyl you join here, and diphenyl, one phenyl you can join here, another phenyl will be here. This is the structure of tri-butyl diphenyl silyl chloride. And what do you here, simply as we know that example is a ROH alcohol, that TBDPSCl treated with this, and you are going to get the product will be this one, TBDPS, and this is a protecting group, and we can deprotect it by using BU4NF in presence of KF, or we can use as a acidic condition. You will get the alcohol back, that is your original position. This is all about the Silyl group. Remaining, I think, remaining protecting group. I think with this we have covered maximum protecting group which are essential or required for the hydroxyl group, I think. And tomorrow onward we may start the remaining functional group and their protecting group, I think maybe as a carboxylic group or maybe as a amino group, NH2 groups are there. So I think with this, let us stop today here. Remaining we will see next lecture. Thank you. Have a nice day.